Hi everyone, welcome back to another Euphoria Academia YouTube video where we do past papers step by step. My name is Ole and I'll be taking you through it. So today we're going to be doing the grade 12 mathematics paper 2 which was written in November 2023. Let's get into it. For question 4, we have 4.1 up until 4.6 and the whole question counts 20 marks. So let's get started with 4.1. Now, with any of the questions done in paper 2, my advice is to always have like the sketch next to you and fill in information as you go. And I found that the questions actually tell you a story. So when you do one thing, it actually will help you in the next question. So it helps to fill in information as and when you know it. All right. Now with that out of the way, for question 4.1, we're asked to show that P is equal to 4, where P is the coordinate of D, so the x coordinate of D, and D is P and minus 2. And we are told that the point D lies on the smaller circle, which we have been given an equation of, right? So this would just mean that we have to substitute these coordinates into the formula of a circle, and we will find what P is. So without waste of time, let's get into it. All right. So the equation of the circle, the smaller circle, is x squared plus y squared is equal to 2. All right. Now, if we sub in D, or the coordinates of D, we're going to find that we're going to have p squared plus, I always recommend substituting and then putting brackets around whatever that you're substituting, minus 2 is equal to 20. Now, after doing some maths, we will find that P is equal to 4. For question 4.2, we're asked to find the coordinates of F, and we're told that point E, which has the following coordinates, 6 and 2, is the midpoint of the line DF, right? And the line DF includes the coordinates of F. So we're meant to find the coordinates of F, which is an x coordinate and a y coordinate. Whenever you see midpoint or halfway, you must think what? Midpoint theorem, right? And the equation of the midpoint theorem is equal to x1 plus x2, your two coordinates, divided by 2, and then y1 plus y2 divided by 2. All right. So we're meant to find the x coordinate of F and the y coordinate of F. Now, when we find that, we can basically just separate these things. So we're told that E is the midpoint, right? So that's the x coordinate and that's the y coordinate. So essentially, we will have a situation where xe will be equal to xf plus xd divided by 2, and then ye will be equal to, this is the y coordinate of point E, will be equal to not x, so will be equal to yf plus yd divided by 2. Now we're just gonna substitute what we have, and what we have is, well, we still need to find xf, but we do have point D, which I have written on the diagram. Like I said, we almost always do. All right, now we're gonna do the same for the yf, that's what we're trying to find. This is actually equal to 6. This will be equal to 2. Yf, what's the y coordinate of D? it is minus 2, and that is divided by 2. And we will find that this will be 12 will be equal to xf plus 4. This will be equal to 4 will be equal to yf minus 2, which means ultimately xf is equal to 8, and then yf is equal to 6. So the coordinates of f are 8 and 6. Right, we're told to find the common tangent df in, well, we're meant to find its equation in the form y is equal to mx plus c. All right, so we already know that we have 3 points essentially on this tangent, right? So for me, I'm going to use point D, which has the coordinates 4 and minus 2, and point F, which has the coordinates 8 and 6. All right, now when you have 2 points and you're trying to find the equation of a line, there's a form called the 2-point form of the equation of a straight line, right? So we're just going to use that equation, and the equation is as follows: y is minus y1, which is your first y coordinate, and x minus x1 is equal to y minus y2, which is your second y coordinate, and x minus x2, which is also the second x coordinate. So what we're going to do is just replace what we have. So for me, I'm going to y1, x1 will be D, point D, and then y2, x2 will be point F. Right, so that will give us y minus 2, and then x minus 4 is equal to y minus 6 and x minus 8. Alright, now we just need to do a bit of algebra here. So what I'm going to do, I'm going to take the x minus 4 to that side, and then I'm going to take the x minus 8 to the left hand side. And how am I going to do that? Well, I'm going to multiply by both. That's how I'm going to do it. So I'm going to multiply the left hand side by x minus 4, and I'm going to multiply the right hand side by x minus 8. Alright, so let's just do that. This is going to give us an equation where we have y plus 2 being multiplied to x minus 8, and then on the right hand side we're going to have y minus 6 being multiplied to x minus 4. Alright, so let's expand our brackets. We're going to see that we're going to find xy, and we're going to have a minus 8y, we're going to have plus 2x minus 16 on the left hand side. On the right hand side we're going to have xy minus 4y, we're going to have minus 6x plus 24. Alright, okay, so you can see that we have an xy on the left hand side, and then we have an xy on the right hand side, so that's going to cancel. That's going to cancel, because if you bring either on one side or the other, it's going to be negative, and it's going to be xy minus xy, which is 0. Alright, So I'm going to try and put all the y's on the left hand side and the x's as well as the constants on the right hand side. I'll just continue on this space here. So we have a minus 8y, minus 4y on the right hand side. If you add it, we're going to be left with a negative 4y. Alright, and now we just have to take the x's and the constants to the right hand side. On the right hand side we have a minus 6x. If you subtract a minus 2x, you're going to be left with a minus 8x. And then if you add a 16 on the left hand side and you add a 16 on the right hand side, you're going to be left with a 40. Alright, let's do some quick algebra. Divide through by minus 4. And we're going to find that we're going to have a y is equal to minus, that's going to be a positive 2x minus 10. Right, so our final equation is 2x minus 10. That's the equation of the straight line. Question 4, we're meant to find the value of t, small t, alright, which is the x coordinate of the center of the big circle. Yeah, of the big circle. Alright, cool. So we know that GF is the radius of the big circle because it's from the center and goes outwardly to touch the circumference of the big circle. Alright, and we have the point F, which is 8 and 6. So essentially, if we're asked to find T, what could help us is substituting this point and another value in our case that's easy to find would be the gradient of the line of GF. So if we have the gradient, we have a point, we can find the equation of the line, and after finding the equation of the line, we can essentially substitute what we need to substitute after obtaining the line, and we can get what our point T is. So without further ado, let us get into it. First things first, let's find the gradient of GF. Well, we know that GF is the radius and the tangent DF that we are told about in the previous questions. And what do we know about the gradients of well, not the gradients, but what do we know about tangents and radii? We know that the tangent is perpendicular to the radius. So that would mean the gradient of the radius MGF multiplied by the gradient of DF is going to give us minus 1. That's what it means. Alright, now we don't know the gradient of GF, that's what we're trying to find. The gradient of DF we found in the previous question when we wrote the equation in the form y is equal to mx. M is the gradient and our m was 2, and by virtue mgf will be equal to negative half. Alright, now we're going to use the gradient point method to find what our t value is. So let us write the equation. The equation will be y2 minus y1 divided by x2 minus x1 should be equal to the gradient, and the gradient in this case is GF. Now, what's our Y2? Well, our Y2 can be G, and our Y1 will be our point F, and that will give us a 6. Point F's coordinates 8 and 6, and at the bottom here, well, we need to find what T is. It's going to be a -8, and that will be equal to -1/2. Alright, now after some maths, I think let me simplify it before we go forward. So essentially what we're going to do is we can move the T -8 to the right hand side, and then move the 2 multiply by 2 on the left hand side, take it to, multiply by 2 on the right hand side and then multiply it on the left hand side. And after some simplification, we will find that T is equal to 20. For question 4.5, we're asked to find the equation of the larger circle in the form ax squared plus by squared plus cx plus dy plus e, and that will be equal to 0. Now we know that the general equation of a circle is x minus a all squared plus y minus b all squared equaling to r squared, which is the radius. We have the points of the center, which is G, and that is 20 and 0. And we have the point F, which is on the circumference of the larger circle, and that is 8 and 6. So we can use these to find what the radius is equal to. And substituting, we will find that our x will get it from point F, 8 minus 20 all squared plus y, our y will be 6 minus 0 all squared, and that is equal to r squared. When you put the left hand side in your calculator, you will find that r squared is equal to 180, and conversely the radius is equal to 6 multiplied to the square root of 5. Alright, so after finding what r squared is equal to, well, we can essentially substitute the r, or the r squared, into our formula, and we will find that our formula now for the larger circle is x minus 20 squared plus y minus 0 squared is equal to 180. After expanding, we will find that we have x squared minus 40x plus 400 plus y squared is equal to 180. Now we just have to write it in the form that they ask us in, and we will find that our form, or to answer the question, we're going to find that we have an x squared. It needs to be followed by a y squared, and that the next one is an x, or constant multiplied to an x, which is minus 40x, and we don't have a y plus 220, and that is equal to 0, and that is our answer. For question 4.6, we're asked that the smaller circle must be translated by k units along the x-axis to touch the bigger circle internally. Alright, so essentially they're asking us by how many units must they move the smaller circle to be in a situation where we have the larger circle and the smaller circle is touching it like this, or a situation where you have the larger circle and the smaller circle touching like this. All right, so in order for us to be in a situation like this, we know that the radii of these or the distance between the radii is going to be calculated by R2 minus R1, R2 being the larger radius, so the larger circle. All right, and we know that the smaller circle lies on the origin and the bigger circle has an x value of 20. So we know that we have to move the smaller circle by 20 first, and then we have to decide how much does it move to the left in order to touch it like this, because if you just move it 20 units, we're going to find that the bigger circle and the smaller circle will have the same center. So we want to move the circle, the smaller circle, either to the left or to the right so that it can touch the bigger circle. So that situation will be created by this guy over here, by having that expression. So without further ado, let us get into it. Well, first we have to find the radius of the smaller circle, right? So we have to find R1. All right, so R1 will be determined by, we do have the formula of the smaller circle, so we can just use that. We can see that x squared plus y squared is equal to r, and we will just substitute the point D that we calculated in the first question. 4 squared plus minus 2 squared is equal to r squared, and we will find that 20 is equal to r squared, and r is equal to 2 multiplied to the square root of 5. Now the k units will be determined by, like we said before, moving it 20 units and then moving it to the left. We're going to subtract that the relationship of R2 minus R1, and that is, we find that R2 was 6 multiplied to the square root of 5 minus 2 square root of 5, and that will give us 11.06 units. And then to move the smaller circle to the right, we're just going to add that relationship like that, and then we're going to find that k should be 28.94. So any of these two situations will give us the smaller circle touching the bigger circle internally.